Okay, here's another question for 5 marks, and it says use a suitable substitution to find the integral of minus 15 sine brackets 5x minus 2 close brackets dx. It does specify a particular method, substitution, even though there is a number of ways to do this, but let's have a go at the maths. It's sensible to always call your integral, as specified in the book, something. And yeah, we'll call it I. So for the integration here, let's start by, let's get rid of that. Yeah, okay, let's call it I. I is equal to, and we'll write that all out, the integral of minus 15 and sine, and we have our function inside the function, 5x minus 2 dx. So we're going to let, it's always sensible to let the function in the function equal u in this case. So let u equal 5x minus 2, and then we can say that du dx is equal to 5. So that tells us, and we'll just write it here, so that tells us du is equal to 5 dx. Oops, better move this out of the way, and so we can create some more space. 5 dx, here we go. Good. And if we follow on from that, our integration then, I is equal to the integral of minus 3. Yeah, the integral of minus 3 sine, and then 5x minus 2. And then in brackets the function 5x minus 2. And then of course multiplied by 5 dx. And that's our rule, because minus 3 times plus 5, so we've got here, and I should change pen color perhaps here just to give you a notification of that. Yeah, why not green? Because we've got minus 3. We got minus 3 here, negative 3 times plus 5, positive. Oops, that doesn't look like a positive. Let's change that. It's real time. I'd like to say that often. You should get to know my patterns of play now. Plus 5, and I write plus 5 here, is equals minus 15. And that's what we need. Yeah, so that's multiplied by our 5 dx. So that's where the minus 3 comes from. Let's go back to our black color pen. Here we go. And if we continue, that will give me the integral of minus 3 sine u. So the integral of minus 3 times the sine of u. And I put that in brackets, du. And that will give us, well, we know that the integral of sine is minus cosine, so minus 3 times minus cos of u, and then of course it's plus c. But now we have to substitute what u is, which is, we let it be 5x minus 2. That was the function, so minus 3 times minus the cos of u is 3 cos 5x minus 2 plus c. And that's another use of reverse chain rule and substitution, using the method of substitution. And there's your 5 marks. Let's have a look. We're okay for time. Let's have a look at another question for 6 marks. using calculus to find the exact value of the integral of pi over 2 with limits pi over 4, pi over 2 and pi over 4 as limits, cos squared theta d theta. But it says given that cos 2 theta is identical and equal to 2 cos squared theta minus 1, we can use that finite integration, trigonometric identity to find the exact value. So let's have a go at that, and let's do the maths. So again, we need to start by calling our integration something. So they're telling us to use identities. So we've got cos 2 theta. Oops, let's change the thickness of the pen. Yeah, it's a bit too thick. We go for that one. That's better. Cos 2 theta is equal to, identical and equal to 2 cos squared theta minus 1. 2 cos squared theta minus 1, which implies that cos squared theta is identical and equal to a half cos 2 theta plus a half. Well, that's nice because I can use that. I'll let my integral be something, and again, the textbook recommends that you call it I, is the integral of limits with pi over 2, and pi over 4. Cos squared theta d theta. Cos squared theta d theta. So that will give us the integral with limits pi over 2 and pi over 4, pi over 2 and pi over 4. I have to write this out. It takes it's time consuming and we're conscious of the time. Again, I'm going to use the identity, a half cos 2 theta, a half cos 2 theta plus a half d theta. Now, with the chain rule, if I just go over here, d theta sine 2 theta, is equal to 2 cos 2 theta. 2 cos 2 theta. And that's from the chain rule. Now, knowing this and using this, I can say, so the integral, and we'll go back to it in a moment just to explain, a half cos 2 theta d theta, a half cos 2 theta d theta will be equal to, and here we go, is a half, and we need to compensate by, here we go, here's our compensation, plus a half, so half brackets, a half, plus 2 cos 2 theta, 2 cos 2 theta, and of course d theta. Now that will give me the integral of 1/4 2 cos 2 theta d theta, 2 cos 2 theta times d theta. And going back and of course, that's the reverse chain rule, really. That's equal to 1/4 sine 2 theta. That will give me 1/4 sine 2 theta plus c. Yep, yes, that's correct, plus c. And that's the reverse chain rule. Now, if I go back, to my integral with limits pi over 2, pi over 4, a half cos 2 theta plus a half in brackets times the theta. Following on from that, using the information that I've just provided, that will give you the integral of, again, with limits pi over 2, pi over 4, and then 1/4. Let's do it. 1/4. What did we make it? 1/4, and then 2 cos 2 theta. 1/4, and then 2 times 2 cos 2 theta. And that will be, oops, I've got to multiply, oh sorry, add a half to it. Apologies, add a half. Yep. Plus 1/2, yes. Plus 1/2, because this is what we have, plus a half. Yep. And then d theta times by d theta. That's going on from that. We can put in our limits now, because we can integrate. That will give us 1/4 sine 2 theta, sine 2 theta, sine 2 theta, plus a half theta, plus a half theta, and with the limits pi over 2 and pi over 4. And let's extend our page, or let's go on, continuing now. So that will give us 1/4 sine pi. So that will give me 1/4, let's put it in brackets, times the sine of pi, plus a half pi over 2. Plus a half pi over 2. And we can put that in brackets. Yep, probably best to. And 1/4 sine pi, put the pi in brackets, let's be consistent. Yeah, and close brackets there. Hopefully you can read my writing. Minus, and then again open brackets, and it's 1/4 sine pi over 2, sine pi over 2, plus a half pi over 4, plus a half times, oops, a half times pi over 4. And we close brackets around that, and close brackets around that. And what does that give us? Well, that gives us 1/4 times 0. Because the sine of pi is 0, so 1/4 multiplied by 0, plus your pi over 4, and yeah, that's the first bracket, and then minus 1/4 times 1. Sine of pi over 2 is 1/4 times 1, so 1/4 multiplied by 1, that's nice, plus pi over 8. Pi over 2 times pi over 4 is pi over 8. And that doesn't look much like a 4 there, so we need to make sure that that's a little bit better. As pi over 4. Right, okay. And let's tidy up. So we've got pi over 4. Sorry, pi over 4 minus 1/4 plus pi over 8. Yep. So we end up with pi over 8 minus 1/4, which is equal to pi over 8. Whoops, let's go down. Pi over 8. Oops, and we're taking some time here. I'm conscious of the time. We don't like to go beyond really 10 minutes, but it's coming up to 15 now. Let's tidy up and finish up. So that ends up with pi over 8 and minus a quarter. And it does say the exact value. Well, you can use a calculator. I haven't got a calculator on the screen, but that's the solution. And I believe that's good.